Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our today's video, we are going to derive time complexity and space complexity for the merge sort algorithm. So let's get started. Assuming that t of n is the function which denotes the number of comparison it takes, right? So if I have only one element, okay, where n is equals to 1, in that case t of n, the time taken for the comparison, or you can say time taken for the algorithm to execute the basic operation, is a single unit. It is 1, right? Now if this n is greater than 1, what we do, we basically divide the problem into sub problems and then we compare. That is, t of n becomes 2t of n by 2 plus n. Now what is this, and how we have got this? So remember that t of n is nothing but 2tn by 2. This 2 is because we are dividing the problem, right? Dividing the problem into into two subarrays, and those subarrays are having the equal elements, n by 2, n by 2. If n elements are there, that subarrays will have n by 2 elements, and then we write function. This function denotes the number of comparison made to merge the two sorted array of size n by 2. So this that is function. So if you see, this is n minus 1, which asymptotically can be written as n. So that is why this t of n is 2t by n by 2 plus n. Now there are two approaches to go. One is through master theorem and what is through normal approach. Normal approach, what it will be? Again, you write, see, you got t of n as 2t n by 2 plus n. Then you put what? You put the n by, again, you need to divide it further, right? So if I need to get n by 2, so what you will write? You will write t n by 2 by 2 plus n by 2, like this, right? And then you put this whole into this, you will get the some expression. Then what you do, you assume 2k as n and then you manipulate it. This we are going to see in the quick sort. So same derivation. Okay, same derivation I'm going to do for quick sort. That's why I'm not doing it here. I'll go with the master theorem here, right? So what you have got t of n equals to 2t n by 2 plus n. So if you apply master theorem, okay, apply master theorem, what you will get? You have a equal to b equal to 2, and you need to find this a and this b, right? That is n log a to the base b and n log this 2. Are you getting it? Now, if you compare, remember master theorem, if you compare this n log b to the base a and with your f of n, so this is also n, this is also n. Which case? When both are same, we fall into case 2 of the master theorem. That is case 2 of master theorem, which says that this t of n is equals to theta of n log a into log n. Now this is, according to this, is what? This is nothing but n only, right? So this is theta of n into log n. Are you getting it? So your t of n becomes theta equals to n log n. And when we were talking in our previous video that there is no stoppage condition, there is no limitation condition in any case, whether it's average, worst, or best case, we need to divide it and we need to merge it. If you remember, I was making this point in the example when we were discussing the examples, right? So there is no point where we need to stop. We need to complete the thing. That is why this thing remains same for average, best, and the worst. So time complexity of merge is n log n. Now if you want to go with this, I can quickly just write it. So what we do, so T of n becomes what? 2t n by 2 plus n, right? Now if you again divided it, what you will get to 2t n by 2 plus 2 plus n by 2 plus n. That is what I have put this thing n by 2 here, okay? Which is nothing but, if you see, it will be 4t n by 4 plus 2n. So 2 into 2 and this n by 4 and n by 2 into 2 gets cancelled. So n or n 2n. Now further if you write it in 4t n by 2, what you will write? You will get it 4 times 2t n by 4 upon 2 plus n by 4 plus 2n. So if you get tn by 4, okay, so instead of tn is 2tn by 2 plus n, put instead of n, put n by 4. You will get 2t n by 4 by 2 plus n by 4. Put it here. So you will get it 8t n by 8 plus 3n. So like this, if you see, this is nothing but 2 power 2 t n by 2 square plus 2 into n. This is 2 cube into t n by 2 cube. Why I am doing so fast? Because I am telling you this way I have derived a quick sort. So there is no difference in that, right? And this this is written as 2 power 1 into t and 2 power 1 plus 1 into n. So if you derive a common result, okay, so can I write the kth will be 2 power k t n power 2 power k plus k dot n. Is that correct? If you see 1, 2, 3, 1, 2, 3, 1, 2, 3. So can I derive the expression from here? Now what you do? You consider 2k as n and apply both the sides. So apply log both the sides. So when you apply log both the sides, what you get? You get, now if that is, if you can write this also, log 2 power k equals to log 2 power n. So log 2 becomes k log 2 equals to log n. Log 2 is nothing but k. So k is log n. Remember the property log a is 1. Log a power k to the base b becomes log k ab. These are the log properties which I have applied. Are you getting it? So k equals to log n. Now if you put this into this, what you will get? Can anyone tell me? 2 power k is n. 2 power k is n into t n upon n. This 2 power k is n plus k is what? This log n multiplied by n. So if you see, you get n into t1 plus n log n. T of 1, remember t of 1 we have already seen. T of 1 is 1. T of 1 is 1, that is n plus n log n. Asymptotically, what is bigger? Asymptotically, n log n is bigger. That's why we write theta of n log n is the time complexity. Let's talk about the space complexity quickly. So space, why I'm doing so quickly? Because all of these steps I have already discussed you while taking the examples, right? So I hope you are at that level where you can understand all of these quickly, right? So space complexity, guys, quickly. You remember when we were comparing the element A and AB, sorry, A of J, what we used to have a temporary array, correct? Where we were incrementing K. So you need O of an extra space because of you are using a temporary array to copy the merge item and then copy back to the original array. So this is an extra space you need. That's why space complexity of merge sort is O of n. So if you like this video, please do like, share and subscribe and stay tuned for the next videos where we are going to discuss about the application advantages and disadvantages, followed by some of the frequent asked interview questions about merge sort. Thank you.